Hello, my name is Matt Eaton, and I'm a graduate research assistant for Dr. Tanvir. Now, this video is a follow-up to a previous video all about how to take a custom robot chassis in a program like Solidworks and how to fully simulate that inside of a ROS environment. Now, this video will be all about how to go through that exact same process, but this time with a robotic arm. There's one extra step that we have to go through that can seem a little bit crazy. That's integrating with MoveIt, but you'll see here in a bit that going through that process is very much worth it because you can have very, very detailed simulations, and there's a lot of really great software packages built in to support robotic arms. Okay, so here we are in SolidWorks. Now, one thing I want to mention, when you're creating a URDF file for a robotic arm, you do not want your actual assembly that you've created for your robotic arm. So like, let's say you have an assembly for your very detailed robotic arm, and as you guys know, when you're creating an assembly, you have lots and lots of different components that you need to add mates to, right? So you might have 50 different mates. You should absolutely create that project. But then what I would recommend, this makes things so much easier, is you want to group your assembly into sub-assemblies in which you're basically breaking up the parts that are actually moving. So essentially, you want to create a sub-assembly for each joint of the robotic arm. And I think this will make a lot more sense kind of as we go through the process. But let's go ahead and get started here. So I'm going to start with my first file. Now, this here is actually a robot arm that I've been working with Dr. Janvier on. And so what's kind of cool is this is one that I've been using that I have built physically in my office. But okay, I went ahead and what I've done is I've separated these into sub-assemblies. Now, the first assembly is just a stepper motor. Now, these are actually really cool stepper motors. This is modeled after an actual stepper motor. It might look a little bit different because these have harmonic gearboxes in them, so they're really accurate. And that's kind of the basis of the project that we've been working on, is this kind of overly simplistic but still very powerful and accurate harmonic gearbox stepper motor based robotic arm. Okay, so here is my my first joint here, and I'm actually going to go ahead and I'm going to add in some reference geometry, just like we did before. So I'm going to go ahead and I'm going to start with here a point, and you know what? I'm going to go ahead and add my base point here first. So this process should look familiar. And I'm going to call this guy the base point. Okay, perfect. Okay. Now, we don't need an axis for this first point, but we do want a coordinate system, our base coordinate system. And if you guys remember, we need to make sure we have all of our axes here correct. So I'm going to go ahead and I'm going to make this guy my z, right, which that's not right. We're going to flip it upside down. But I have x. Actually, it doesn't really matter if we make this the front or vice versa. So let's go ahead and do that. So we'll say that this is the front here, because as we recall from the last video, x should be forward, y should be to the left, and z should be up. So that'll actually be good for now. Let's go ahead and leave that there. And then also, of course, we're going to rename base CS. Okay, awesome. All right, so now we want to add in our first axis. So this is the base rotation here. So let's go ahead and we're going to basically do the same thing again. So I'm going to create my point, create my axis. So if you guys remember, whenever you press the axis button, your point is already highlighted. So all you need to do is click on the face, and it automatically puts that axis there for you. And we do actually need a coordinate system for each joint, just like before. So the position of this is going to be 0.2. Obviously. And here we want to remove this because this is not what we want. We want to add in our Z and flip this sucker. There we go. Okay, awesome. I think that was really helpful for us to just kind of build our system around the coordinate that was already there. So now you can see Z is up, X is forward, Y is over there to the left. All right, so I'm going to oh, here, this is really important here. We're going to call this joint 1 point. Joint one axis and joint one coordinate system, CS. All right, this is the kind of thing that it's going to seem like this is really annoying to change all of the names, but it's going to get really, really complicated, the document. So we want to make sure that that we're really setting ourselves up for success later. Okay, so let's see. Don't show this again. Okay, sorry about that. All right, so we're going to go ahead and add in our second subassembly here. So I'm going to go into here. And I'm using step files, so this is why this is a little bit different. You could do the exact same thing with subassemblies. It does not matter. But I'm going to go ahead, grab this guy. Okay, so as you can see, this subassembly has a lot more going on. There's a few more components here. But what I'm going to do is I'm going to put this guy right here. Again, it doesn't really matter. Now, okay, here we have the front of our robotic arm. We kind of want to make sure we keep track of that. Okay, but we want to make sure that we have the least amount of extra joints possible. So as you guys, I'm sure you guys know, you have many different joints inside of subassembly, right? So here we can see we have all kinds of different, there's a joint there and a joint there, but we don't want that in our main document. So what we're going to do is we're going to set this up so we want as few joints as possible. And so it's really important that we go edge to edge, not face. So here I'm selecting the face. Here I am selecting, this is tricky, the edge that I want. Perfect. Okay, so I can verify edge. And then I'm going to make sure I select this edge as well. Okay, perfect. And then I'm going to go face to face. Okay, awesome. So I have 2 joints there, which is good. All right, and that's good to go. And so as you can see, this guy can rotate now, no problem. Now I'm going to go ahead and I'm going to orient this guy correctly. So X is forward. Now this is kind of funny here. I don't know if this is good practice or not, but I'll usually click on 2 edges that I know need to be parallel, and so that you can see it makes a parallel mate. Does that make sense? And then I'll actually go through and I will delete that parallel mate. And I'm going to keep it there, right? I want to make sure it's nice and aligned, but I don't actually need a parallel mate there because then I can't rotate my arm. Okay, now this is really, really important. So now here we have our joint 1 axis. Okay, so now my joint 1 axis, you can see there, right here, is in the middle of this arm. And so this, again, is kind of tedious, but you have to add in your axes, your points, and your coordinate systems before you make each mate. So you don't want to, you don't want to, use mates and create your entire assembly and then add in those joints and those various axes, because then you can't click inside of something that's already mated. Okay, so now what I'm going to do is I'm going to go ahead and import all the rest of this stuff here. And I'm going to create those axes the exact same way that I did previously. And so I'm gonna speed the camera up here, but just know that I'm basically repeating the exact same steps that you guys saw before. I figure you guys just don't want to watch the entire thing happen here. Okay, so that took a minute, but we got everything we needed to done. So it'll be a good idea to check all of your coordinate systems here. So here we have x facing forward, x is facing forward, x is facing forward, x is facing forward. There we go. Okay, we look good. Okay, so this is a 6-axis configuration here, and so what's nice about having a 6-axis robotic arm is, like simple robotic arms, they can navigate their end effector to a specific position, right? That's no big deal, like position in XYZ Cartesian space. But more advanced robotic arms often want to separate the concept of position as well as orientation. And so orientation referring to the angle at which the end effector is kind of like interacting with something. And so what's nice about this 6-axis arm is you have 3 axes dedicated to your position, and then you can separate your orientation. So it's kind of like with this configuration, it's almost like the top half is just a mini version of the bottom half. We kind of repeat those coordinate systems and things. So also at this point, I have not put any fingers on the gripper because I wanted to show you guys how to do that kind of not sped up, just because it's a little bit different. And so typically within the software MoveIt, you want to separate your gripper from your arm. And the process might seem kind of crazy, but it's really not too difficult. And so what I'm going to do is I'm going to go ahead. Oh, also, I wanted to mention. So we checked all of our coordinate systems and the axes and things. It's also a good idea to just make sure everything's nice and straight. So I was talking about you can add in those parallel mates and then delete them. Honestly, I think that's a good idea. But I'll leave that up to you guys. But that should be good to go there. Okay, so now we're going to add in the fingers of the gripper. And so it's not that difficult. All you're going to do is, though, your axes are going to be facing inward here. And there's also some setup stuff that you have to do in order to get this to work as you do your export. And so that'll be really important to get that correct. Okay, so I've got one of the fingers of my gripper here. What I'm going to go ahead and do is I think I'm going to do the edges here. It does not really matter which items you do here, so long as it slides properly. And also, too, the likelihood that you guys are using the exact same gripper I am is pretty low. But I did want to show you guys this. So here, I'm going to go ahead. I'm going to try to do this. Let's see if this will work. No, it won't. Okay. So let's see if we can convince this thing to cooperate here. Okay. I'm going to fix this guy in place. There we go. Okay, so perfect. Sometimes you have to, convince SolidWorks to play nice. Okay, I'm going to try to go. You know what? No, here I'm going to go like this. I'm going to say this face should be coincident with this guy. Okay, that'll work. All right. Okay, that makes sense. See, it didn't work before because this isn't perfectly aligned, which is totally fine. So I did this edge and then this face here, and that should work. I more than likely messed up my straightening out here. Oh, there we go. But we'll fix that. We'll fix it a little bit later, just in case we get more messed up later. Okay. Awesome. So I'm going to go ahead and I'm going to fix this guy in place again just so it doesn't mess us up. Okay, cool. We have this guy sliding. Awesome. Okay, so now I'm going to go ahead and set this guy up the exact same way. Oh, there we go. See, I accidentally made a face instead of an edge. Easy mistake to make. Okay. Okay, good. It's still fixed in place. Okay. Oh, darn it. I did that backwards. Oh gosh, you guys are probably watching the video, seeing me make that mistake here. Okay. I'm just going to go ahead and I want to make sure I do this guy right. And so I'm going to get it as close as I can. Just to make sure I don't make the same mistake twice. Okay, there we go. Now we should be good. Edge to edge. Okay, guys, we made it. Look at that. Oh, also too, normally with this gripper, in the physical world, we have a servo here that's connecting with some other hardware. We're not going to bother modeling that because there's just not really much sense in using the resources for that. You'll notice too that this model is much more complicated than the chassis that I built in that last video. And this level of complexity isn't really that bad, depending on the hardware. So if you want to, you could totally do just super oversimplifications of this stuff. But I already had these models around, and I know I've used this model before, so didn't have that same issue. Okay, so let's go ahead and let's try to straighten the sucker out again here. So I'm gonna add these guys in. Make a parallel mate. Oh, that wasn't happy. Didn't like that. All right, I'm gonna go ahead and speed this up, and we'll get this straightened out. Okay, I got that figured out. Sorry, that was my bad. I still had this guy fixed, so I couldn't move it, and so that's why I couldn't. Those mates weren't working. But okay, so now we have the arm nice and straight, good to go. Now we still have to add in our coordinate systems and our axes for this stuff here. So we're gonna do that the exact same way as we did before. So I'm gonna go in this middle position here, and then we'll see in the URDF file how we need to export this. Okay, guys, we have the whole thing done. All right. Thank you for your patience as we got through that. So as you guys saw, typically the axis for each joint would be going, in that direction of rotation. But these here are a little bit different. So you can see we have this axis that's kind of going in that direction, and then this axis, there we go, going in that direction. Okay, so we are ready to export as URDF. And so the process is not going to be that different from what we saw in the previous video. Also, I want to mention that you can automatically generate the coordinate systems and the axes in the URDF exporter. But I would absolutely positively not recommend doing that. You'll find it's actually a lot more trouble than it's worth because a lot of it will be incorrect. And it'll actually be more work in the end. But I just wanted to mention that. Okay. Export as URDF. So there's that automatically generate. Okay, so I have my base link, which is not what I want to do. So I want to, I don't know what automatically generate. So I have my base coordinate system, and I'm going to go ahead and click on that piece right there. And okay, this is where it's really important here. If you guys recall, for the rolling chassis, we had one base link and we had 4 child links in terms of the parent link and child link. Now that is not how we're going to build this robotic arm. We need these to scaffold. Each link is going to be next to, or it's going to be underneath the other. So I'm going to go ahead and I'm going to call this link 1. joint 1, joint 1, joint 1, continuous. There we go. And I'm going to select the next joint in my arm. Okay, perfect. It's a good idea to make sure all of these are correct, that they're spelled right. Looking good. I'm going to add in one child link, then click on that child link. Link 2, joint 2. And like I was saying before, this is why it's really nice to name everything. Because if this was just a bunch of numbers and names and things, it would get really, really complicated. And it makes this step really easy. Okay, so at this point, I wanted to take a break here because it's going to be a little bit different. So as you guys have seen, I have these cascading links here. And link 6, that is the base of my gripper. We're counting that as, part of the arm. And so now, instead of just one child link, here is where we want 2 child links. I know this is kind of hard to see here, but it's going to be a little bit different here. So I'm going to click on this link, and I'm going to call this, no, I should keep the same convention. So link 7, joint 7, grip 1. I don't know. I probably should have kept these the same, but whatever. Okay, so now here, we want to make sure that we have prismatic as the joint. That's going to be really, really, really crucial here. Okay, so that looks good. Okay. Joint 8. Now don't be confused there, because this is the parent link, so know that this is 8 because we just did 7 here. Okay, grip 2, prismatic, perfect. Okay, sorry guys, I know this is kind of hard to see, but this is perfect. This is exactly what we want. And now let's go ahead and do preview and export. All right. Okay, so this looks good. Joint 1, joint 2, joint 3, joint 4, joint 5, joint 6. Now here, for these joints, for the rolling robot, we had to switch this stuff on the axis. We do not need to do that here, although there is something super, 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 super important. We have to add a limit. Now, this took me so long to figure out. I spent weeks on this problem. So the prismatic joints will only work if it has a limit, because essentially it'll look like it's fixed in place whenever you try to simulate this, which is really, really, really annoying. So this is in meters. So I'm going to go ahead and I'm going to say 0.2. Actually, no, I think this should be negative 0.2. Oh my gosh, this is so annoying too. You can't do a point unless you have a number there. I don't know. I'm hitting the point right now. So okay, 2 point. Really annoying here. Okay, so 2 point. Okay, I'm pretty sure this is how we do this. Sorry guys, it's been a little bit. There are a lot of steps involved, but I'm fairly certain that this is how we want to do this. So we have a lower limit, upper limit of negative 2.2 meters and positive 0.2 meters. And I do not believe that we need this. Actually, let's just put 1 and 1. I don't think that matters, but we're gonna see. Okay, we're gonna do the same thing here. 0.2, and I apologize if this isn't correct. We'll go back and change it if we need to. I'm pretty sure this is how we do this. Again, it's been a couple weeks since I've done this. Okay, awesome. This looks good. All right, so we've added our limits to our prismatic joints. The rest of our stuff, it looks totally fine. Gonna hit next. Okay, so now we want to make sure that we have our inertial data, right? Doesn't really matter what it is. Just want to make sure that we have it. Okay, perfect. This looks great. So now we can go ahead and we can export our URDF and meshes. And we will go from there. So then we'll export this. Remember that will create the ROS package for us, and then we'll hop into our virtual environment to take care of the ROS setup. Okay, guys, I'm here inside my Ubuntu environment, and I have gone ahead and moved the file that we just exported into my Catkin workspace. So this was NTRE ARM. That's what I decided to call this, just kind of keeping things on theme. So this is the file that we messed with, if you guys recall, last video here. So let's go ahead and let's back up one place, and we need to make sure we compile, make sure we're good. Okay, awesome. All right, so let's go ahead and we're going to resource. Okay, so MTRE, there it is, NTRE underscore ARM. Okay, so let's go ahead and let's go inside our folder. I want to show you guys what we have here. So, okay, so as before, we have a display.launch and a gazebo.launch. So I want to show you something. Actually, yeah, let's go for it. Okay, so the gazebo.launch, I want to show you guys. The ARM will not automatically work in Gazebo because Gazebo is a physics simulator. So there's going to be a follow-up video in which we add the ARM onto the chassis and kind of go from there. And so I'm going to wait to show you guys that. But I wanted to go ahead and show you here. So the reason why we need to add in some of the URDF stuff that we did in the last video. So here, if you guys take a look here, load up. Because this is a physics simulator, check it out. Here is our poor robot arm. It has fallen on the ground, right? And that is not what we want. And so what's cool is this problem is absolutely, totally fixable. But this is not what we're going to cover in this video. This will actually be in the third video. So what I wanted to show you here is, let's go ahead and we'll exit this. It's the display.launch. That's what we want to launch because that will launch RViz. And so RViz is kind of the default way to control the MoveIt interface, which is the ROS package or ROS framework dedicated to robotic arms. So let's go ahead and we'll do cd dis. Oh, sorry, not cd. Launch display.launch. Okay, awesome. So it is a good idea to take a look here at this file just to make sure that it's done correctly. So first off, there's an error here. Super easy. Your fixed frame should be your base link. Okay, awesome. So the base link is the fixed frame, which makes sense, right? And then so we need to add in a robot model. There we go. Look at that. Okay, so this all looks correct, right? Looks good. Also, too, what's kind of cool is this join states window pops up automatically. So let's see here. I wonder what happens if we go 8. There we go. Look at that. Do you guys see how that works properly? And what's really cool is you can actually see those limits we put in. You see that -2, right? Which obviously 0.2 meters was way larger than we needed, but we still wanted to make sure we weren't too small. But what's cool is all of our joints work properly. Now, obviously, the way that we do this is not how we actually want to control our robotic arm. We want to do way cooler stuff than this. So I'm going to go ahead. I'm going to center all of these. But what's cool is this is a solid test. This tells us that everything that we thought was going to happen was going to happen. So we can rotate here and take a look. Okay, so that looks good. I'm going to go ahead. I'm going to close out of this because again, we need to run through we need to make some changes if we want this to actually be useful here. So I'm going to go ahead and get rid of all this, but that was a solid test. Okay, so what I'm going to do now is I'm going to say, I'm going to go ROS launch, move it, setup assistance. Okay, so move it, setup assistance, and then setup assistant.launch. Okay, perfect. So ROS launch, move it, setup assistant.launch. Now, I'm not going to go through the entire setup process or installation process for MoveIt. It is well documented on the wiki, and I think you'll probably do that as part of your class or something. So I'm not going to go over that entire thing. But this is MoveIt. If this is your first time seeing this, I just wanted to explain it just a little bit. And so MoveIt is a framework within ROS. That's not built in. You do have to install it, but it is incredibly popular. So there are tons of industrial robots that use MoveIt, and also, as we're seeing today, it's very easy to add in a custom robot model. And so what's cool is, like, obviously we can calculate inverse kinematics, forward kinematics of robotic systems by hand. But when we have super complex inverse kinematic solutions, like we want to use linear Cartesian paths and that kind of stuff, it is much more efficient to have the computer do that for us. And so this is a really, really powerful package. And what's cool is, like, you can try to run different kinematic solvers, and then compare the results and do all kinds of other cool stuff. And so it's a very, very powerful tool. Okay, so I'm going to go ahead and I'm going to create a new configuration package. And so what we need to do is we need to find the URDF file that we just generated. So I'm going to go into my source folder, mtre arm, URDF, and click on the URDF. Okay, awesome. Then I'm going to hit load files. We're going to cross our fingers, hope everything works well, and it does. Look at that. I'm going to make this a little bit bigger here. Okay, you guys can see our arm was loaded in properly, so that's good. That's cool. Okay, so it's a good sign. Okay, so now there are a lot of things that we need to do here, and so this may be kind of tricky to remember. I would probably take some notes, or you can rewatch this video. Okay, so first things first, we're going to generate a collision matrix. This is to see your self collisions. Honestly, you don't have to go to a super high sampling density like I just did. It's going to take an extra 10 seconds, and then you're going to hit generate collision matrix. And so this just makes sure that it shows all of the different ways in which you could be in self collision. That's another thing that's nice about this program, is it'll help you with that. Okay, you do need to add in a virtual joint, but this you're just going to call virtual joint. Whoops, parent frame. Okay, awesome. So virtual joint. Okay, planning group. This is really important. So this is how you separate the arm from the gripper. So I'm going to go ahead and I'm going to add a group, and I'm going to call this one arm. I'm going to do the KDL kinematics. That's what I've enjoyed using. Honestly, I don't think you can really go wrong. Okay, and so I'm going to go ahead and I need to add things to this planning group. So I'm going to go ahead and add different joints. And I'm going to add in all of these joints 1 through 6, basically. Yeah, honestly, I don't remember if you want to add in the virtual joint. I kind of think it doesn't. Oh, yeah, we do, clearly. Okay, sorry. So virtual joint through 6. Okay, awesome. So the reason I realized that we do need the virtual joint is I stopped. It didn't highlight the bottom joint there, so that's my bad. Again, it's been a little bit since I've done this before, or since I've done this last. Okay, cool. So we have the base of our robot with the exception of the fingers of our gripper. That's perfect. I'm going to go ahead and move these over, and I'm going to hit save. Okay, so I'm going to go ahead and add a group, and then we'll call this gripper. Once again, KDL, add joints, and then we'll add in those last 2 joints. Okay, perfect. Okay, so we have our planning groups. We have one planning group for the arm and then one planning group for the gripper. Okay, this next part is optional, your robot poses, although I really, really like doing this. So I'm going to go ahead and essentially we're just creating some default poses. right? So you can have like a default pick and a default place. One of the reasons why I really like doing this is it's a good way to get started. So like, okay, let's see, what is this looking like here? Okay. Let's see, this is acting kind of strange. I feel like this is already in collision state for some reason. Let's see. There's a chance I did something wrong here. Let's see. I'm gonna go like here. Okay. Maybe not. Okay, my bad, guys. Sorry, I was confused. I thought for a second that it was in collision state, just because that's kind of what it looks like. But this is crummy. Let's see here. Okay. Sorry, guys. I know this is super exciting here. Okay. We're going to do something basic here. I just want to make sure this doesn't go into collision state. I think in the physical robot that we have, this isn't quite as extreme. Okay, that should be good. Okay, awesome. Sorry about that. Okay, I'm gonna call this pick, save, add pose, place, save, add pose, up. Okay, so this is what I like to do, even by default, is I'll just have a pick, a place, and then sometimes I'll even do like an intermediate point, but here I'm just gonna do a straight up and down pose. And that just makes things easy to reset. So that's good. Okay, so I'm gonna also one for the gripper here. Okay. Perfect. Okay, and I'm gonna call this guy open, obviously. Okay, great. Okay, sorry for the confusion there about that stuff. Okay, so now I have pick, place, open, closed. Okay, awesome. So those are some good default poses that I can work with here. Okay, so end effector. I do need to add the end effector here. So I'm just gonna call this something boring. Effector. And the parent link is going to be link 6. That's this link right here. And that should be good to go. So the 7 and 8, if you guys remember, those are the fingers, right? So this is the parent link of the end effectors, which would be this guy right here. So that looks pretty good. We've got that there. Passive joints. We don't need any passive joints. We will use passive joints whenever we add in the chassis in the next video, but that we don't need that right now. Okay, so now controllers, joint controllers. We are going to need to add a controller, but all we really need is a position controller. So there are really cool advanced things that we can do. So the controlling the velocity of the motors and things like that. But I'm just interested in a position controller because that'll allow us to set angles for the different motors, which is really all we need to do right now. So I'm just going to call this guy position controller. Okay, so add planning group, and I'm going to add in the arm. Okay, awesome. That's actually all I need to do for that. Simulation, do not mess with this. It says that in order for a gazebo to work, you need to update and change this stuff. I absolutely would not do that. I'm going to show you how to do this in gazebo myself, and I've never had this work for me, so we'll go off of that. Okay, 3D perception. Do not need that information. This is really annoying, but Not that that's actually posted anywhere, but I think it's annoying that they make you do that. Okay, so I'm going to go ahead and I'm going to browse to where I want this to be. And so I need to don't just click the export button. You're going to want to navigate back to your folder here, catkin mtre arm. Okay, perfect. Except I'm going to add in the MoveIt tag, so it creates a different folder here. So I'm in the exact same source folder, right? All of that, but now I have MoveIt at the end. So I'm going to go ahead. Now I'm going to generate my package. It says it was generated successfully, so I can exit the setup assistant. And so now you're going to see there's a huge, huge difference. Okay, so let's go ahead and recompile because we have our new package that we've added. Okay, looks like we're good to go. All right, I'm going to resource. Okay, sorry, that was a lot. Okay, so all I did there was I navigated to our new folder, right? And I just wanted to show you what's inside. So here I have way more example files. These are all MoveIt based. Now, don't get too excited because like the joystick control, all of that, honestly, it's going to take some work. It's not quite plug and play. But there is some really, really cool stuff that we can do. And so what we want here is we want just demo.launch. So I'm going to go ahead and we're going to launch that guy. All right. Okay, so there are a couple of cool things. Let me see. Oh, okay, we can ignore that. All right, we have our arm, and you'll notice it is already in one of our poses, right? Okay, now I'm going to show you guys something here. So in this motion planning tab, there's a couple of really cool things we can do. So one of the first things I want to show you guys do is to change the goal state. So right now it's in current, and I'm going to change this to up. And so you'll notice there is my goal state, and it is in that place that we called up. And so in order to move the robotic arm to that position, you're going to want to hit plan and execute. And so now it goes. All right, so one thing I will say, I hate that this is repeats itself by default. So in case you're curious about how to change that, loop animation underneath the planned path is how you turn that off, which I don't know. Maybe you guys don't think it's as annoying as I do, but I think it's pretty annoying. So I'm going to go ahead. I'm going to go pick, plan and execute. Perfect. All right, we can basically just test. So place, there we go. So what's cool is it knew that that was the easiest way to get there. I'm going to go back to up, plan and execute. And also what's worth mentioning, guys, at this point, everything that I'm doing over here, I can also do in software. So I can write software that will, add new paths. It will get you to do all kinds of cool things. Like in the master's program, we go through some assignments in which you need to make the robot arm, control a cube, or I'm sorry, draw out a cube and stuff like that. Okay, so also I want to go ahead and I'm going to change the planning group to the gripper because I want to make sure and verify that worked too. So I have closed, open. Look at that. Kind of cool, right? So now you can write software to open and close the gripper too. Okay, I'm gonna change this back to the arm. Okay, and I want to show you guys something really awesome. So now, if you guys notice, I can do all kinds of really complicated stuff here. So like, let's say I wanted to now move this robot arm in a Cartesian path, right? So like, the robot does what it needs to in order to keep that line in the x-axis straight. I can absolutely do that. Now, it would take me a very long time to show you guys in software how to do all of this stuff, but I want to show you just how powerful this is. So this is one of those reasons why you want to create, or why it's nice to have this 6-axis, because like I said, I haven't changed my pose at all, right? My pose in XYZ space has stayed the same, but what does change is my orientation, right? Now, I guess it's my pose relative to the joint right there, which may or may not be what you want. But as you can see, it is very, 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 very powerful. And so what's cool is you can create all kinds of custom robotic arms, and you can make all kinds of software to do really cool stuff with it. And so this is really good software for robotics research. And what's cool is, also too, it's very possible. It's actually not difficult at all to write a ROS package that can take all of the angles, right? So like here, if you look at your joints, right? If I put this on pick and plan and execute, so it's really easy to create a script that will read these joints and then export them via UART to a microcontroller or something that's plugged into an actual physical robotic arm. It doesn't have to be a microcontroller. Whatever it is that you're using to control a custom arm. And so it's actually really easy to create, go from simulation to a physical robot. Just like we saw, in the last video about the chassis. And so I hope you guys enjoy this. I hope this made sense. There are a lot of steps to getting this to work. But what's nice is you only need to do those setup steps once, and then you have a really cool model that you can do all kinds of fun stuff with. So I hope you found this video helpful. And again, I hope you guys are looking forward to whenever we put this chassis, or we put this arm on top of the chassis, and then you can actually control both independently. And that's when things get really, really, really exciting. So good luck, and I hope wish you guys all the best on your robotics engineering journey.